observe time dilation in early universe. Events appear to unfold 5 times slower when universe was a tenth of its present age, an effect predicted by Einstein. Astronomers, let's see how to pronounce it. Astronomers have watched the distant universe running in slow motion, marking the first time that a weird effect predicted by Einstein more than a century ago has been observed in the early cosmos. Let's see how to pronounce Einstein.
Einstein.
The scientists found that events appeared to unfold 5 times slower when the universe was a mere 1 billion years old. I think 1 billion years old. Let's see how to read it.
1 billion.
1 billion, yeah, 1 billion years old, or about a tenth of its present age, because of the way the expansion of the universe stretches time. We see things changing about 5 times slower than today, said Geraint Louise, a professor of astrophysics and lead author of the study at the University of Sydney. It is like watching a movie with the speed turned down. According to Einstein's theory of general relativity, astronomers should see ancient cosmic events happen more slowly than modern ones. The effect, known as time dilation. Let's see that, time dilation. Dilation, not dilation, dilation, is driven by the expansion of the universe as laid out in the scientists' fundamental exposition. Let's see, exposition of gravity in 1915. One consequence of the expanding universe is that light is stretched as it travels across the cosmos, making the wavelength longer. The effect causes ancient galaxies to appear redder than they are. Radar. Is it radar? Let's see.
Redder.
It's from red. Redder than they are, or redshifted, but time is also stretched. Let's see how to pronounce it.
Stretched.
If a distant object flashes once every second, the expansion of the universe ensures that more than 1 second elapses between the flashes by the time they reach Earth. Astronomers have previously seen stars explode in slow motion, with the flash and fade unfolding at roughly half normal speed from when the universe present age, but attempts to see time dilation in the very early cosmos by observing extremely bright distant galaxies called quasars. Let's see how to pronounce this galaxies. Quasars had failed to find the effect. Lewis and his colleague, Dr. Brandon Brewer at the University of Auckland ran detailed statistical analysis on 190 quasars observed over 2 decades and found that, contrary to earlier work, cosmic events did appear to unfold much more slowly and the early universe. The key to their success, described in Nature Astronomy, was to find the equivalent of a clock's tick in the quasars' rich and erratic light displays. While astronomers fully expected to see time dilation in the ancient universe and were puzzled as to why earlier work had failed to spot the effect, the prediction still had to be spotted. To be tested. Lewis said, on some level, this builds confidence that we know how the universe operates, he said. We have this picture given to us by Einstein, and we tested it. A good scientist doesn't take these things for granted. You have to keep testing. Professor Brian Skimted, I think this is a German name, I suppose, and astronomer at the Australian National University in Canberra, who shared the Nobel Prize in Physics in 2011 for discovering the accelerating expansion of the universe, said, science progressed by continually testing the predictions of theories. In this case, Lewis and collaborators have extended the time dilation studies undertaken previously with supernova. Let's see this word. Okay, struggle to pronounce it.
Supernovae.
Supernovae. Let's see, supernovae to larger distances, he said. And while they have found that once again, general relativity has predicted what has been observed, this clears up some potential concerns around time dilation seen in quasars from other studies. I think I finished this article. I'm gonna go for another one, which is 6 planets to appear in alignment next week in rare celestial parade. This was on 31st of May 2024. Let's see. Yep, I think wow, let's see how it's the other one. Smaller than the previous, to be honest. 6 planets to appear in alignment next week in rare celestial parade. Celestial. Let's see how to pronounce this word.
Celestial.
It's celestial. The first one is correct. Mercury, Mars, Jupiter, Saturn, Neptune, and Uranus will be visible. Viewers may need some equipment to see them clearly. Let's see how to pronounce this planet name.
Mercury.
Yeah, and the one this good, and I think this Neptune, I said. Oh no, oh girl, you can't go there.
Neptune.
And I think I said Uranus. Let's see if it's correct.
Uranus.
Not Uranus. Uranus. Stargazers are in with a chance of a celestial trait on Monday, with 6 planets appearing in alignment. Mercury, Mars, Jupiter, Saturn, Neptune, and Uranus will take part in the parade, which occurs when planets gather on the same side of the Sun. Professor Danny Stice, I suppose, of the University of Warwick said the event, which should be visible around the world, was due to occur around sunrise and would be rather low in the east, meaning would need some equipment to see properly. Uranus and Neptune. Neptune, I think I pronounce it incorrect. Let's see it again.
Neptune.
Neptune, it's Neptune. Neptune will be faint, so viewers will require good binoculars to see them, he said, adding that proximity of Jupiter and Mercury, the Sun, would restrict the view. Some of the planets may be visible to the naked eye, although scattered light might still cause difficulties. Mars and Saturn are the more accessible ones to view. You can see them ahead of the other planets, rising and a bit higher in the sky. Zeiss said, adding that mobile apps could help show where and when to look up. The planets will appear in a diagonal. Let's see this word. Diagonal? Is it diagonal? I don't think so.
Diagonal.
Diagonal arrangement across the sky, with Saturn highest, followed by Neptune, I think, the Mars, Uranus and Mercury. Jupiter will appear closest to the horizon. Dr. Grant Kennedy, also of the University of Warwick, said, we see the Sun in both hemispheres and the planets are not too far from the Sun. So Saturnus, let's see how to pronounce it.
Southerners.
Southerners have similar chances of seeing the planets. The parade is expected to last for several days, while the same planets will align, albeit in a different order, in August and January 2025, with 7 planets due to align in February next year. Yeah, we'll see them. So I think maybe there will be quite a few similar events over the next few years, because the outer planets move quite slowly and Earth moves quite fast, said Kennedy. But he added, if we were to wait for this specific configuration to go away and come back again, we will have to wait much longer. Indeed, planets are expected to align again in March 2080. That group includes Venus and not Neptune. No, again, Neptune. I'm struggling. I don't think it's Neptune again. Neptune. Once Uranus and Neptune have moved on in their orbits and are no longer near each other on the sky, it would take around 100 years until Uranus catches up to Neptune, so they appear nearby on the sky again, and then we would have to wait for the other 4 outer planets. This word, it's popped twice.
Outer.
Not, I said outer, it's outer. Outer planets to also be on the same side of the Sun to see a parade, Kennedy said. Kennedy. Yeah, whatever.
Parade.
Let's see how to pronounce his name. The professor, let's see how to pronounce his name.
Kennedy.
It's Kennedy. I didn't think it could be Kennedy. Dr. E.D. Bloomer, an astronomer at the Royal Observatory, Greenwich. I don't think it's Greenwich. Let's see if it's
Greenwich.
It's Greenwich. Greenwich warned planet watchers not to look at the Sun while searching for the planets to prevent eye damage, and said for the best chance of glimpsing the parade, they should head to a dark field or park and look to the east. Bloomer added, while he may take a look at the celestial event, it will be occurring very early in the morning. I'm not going to lie, he said. I'm probably going to be asleep. Yeah, go to sleep, man. I think I need to read another article for today. I'm going crazy with reading today. Astronomers detect water world with a boiling ocean in deep space. Let's see this one here. I have no one is well annoying me at the moment because I see a sign for family annoying me. Astronomers detect water world with a boiling ocean in deep space. Exclusive, significant discovery made by James Webb Telescope provokes disagreement over conditions on planets. Astronomers have observed a distant planet that could be entirely covered in a deep water ocean, and findings that evidence the search for habitable conditions beyond Earth. The observations by NASA's James Webb Space Telescope JWST revealed water vapor. Is it vapor? Let's see.
Vapor.
Its vapor, surprisingly, and chemical signatures of methane and carbon dioxide in the atmosphere of the exoplanet. Let's see this word. It is a new word, I suppose.
Exoplanet.
Exoplanet, which is twice Earth's radius. Is it radius?
Radius.
Yeah, correct. Radius and 70 light years away. This chemical mix is consistent with a water world where the ocean would span the entire surface and a hydrogen-rich atmosphere, according to researchers from the University of Cambridge, although they do not emphasize. Let's see this word. I think I saw this word before.
Envisage.
Envisage a balmy, inviting seascape. Balmy. I said balmy.
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 The L is silent. Balmy. The ocean could be upwards of 100 degrees Celsius or more, said Professor Niku Medhasdahan, who led the analysis at high atmospheric pressure. An ocean this hot could still be liquid, but it is not clear if it would be habitable, he added. This interpretation is favored in a paper published in the journal Astronomy and Astrophysics Letters, but it is disputed by Canadian team that made additional observations of the same exoplanet, which is known as TOI 2270b. Let's see this word. Not you. I'm not gonna go for a link.
Disputed.
They detected the same atmospheric chemicals, but argue the planet would be too hot for liquid water, possibly 4,000 Celsius, I think, and instead a rocky surface topped by an incredibly dense atmosphere of hydrogen and water vapor. Whichever view wins out, these latest observations showcase the stunning insights James Webb is giving into the nature of the planets beyond our solar system. The telescope captures the starlight that has been filtered through the atmospheres of orbiting planets to give detailed breakdowns of the chemical present. From this, astronomers can build up a picture of conditions at a planet's surface and the likelihood of life being able to survive there. The evidence for TOI 270D's ocean is based on the absence of ammonia. Let's see this word. I said ammonia. Let's see.
Ammonia.
Wow, it's correct.
Ammonia.
Ammonia. Where is it? Ammonia. Where are you? Ammonia. Ammonia, which basic chemistry predicts should occur naturally in hydrogen-rich atmosphere, but ammonia is highly soluble. Let's see this word. I think it's new word for me.
Soluble.
Soluble. It's soluble. Soluble in water, and so would be depleted. Yeah, another word that I couldn't pronounce it.
Depleted.
Depleted in the atmosphere if there were an ocean down below. One interpretation is that this is a so-called Haitian. Is it Haitian?
Hycene.
Hycene, I don't think it's Hycene. World with a water ocean under hydrogen-rich atmosphere, said Madhasudan. What is this name? It's so difficult to pronounce it. Conditions would be very different from those on Earth. TOI 270D is tidally. Wow. I can't pronounce this word. Let's see how to pronounce it.
Tidally.
Tidally locked, meaning one side permanently faces its star and the other is bathed in internal darkness, creating an extreme temperature contrast. The ocean would be extremely hot on the day side. The night side could potentially host habitable conditions, said Mada. Let's see how to pronounce his name. I think it's an Indian name, maybe.
Madhusudan.
But there would be a crushing atmosphere with tens or hundreds of times the pressure at the Earth's surface, and steam rolling off the ocean. The waters are likely to reach depths of tens to hundreds of kilometers with a high pressure ice seabed. Let's see, is it seabed?
Seabed.
Yeah, seabed, and beneath that a rocky core. Okay, this name is, I think it's a German name. Professor Bjorn Benecke of the University of Montreal has carried out additional observations of the planet and questions the Haitian world hypothesis. The temperatures in our view is too warm for water to be liquid, he said, adding that the atmosphere appeared to contain substantial amounts of water vapor, too much for the existence of an ocean to be plausible. Let's see this word.
Plausible.
Yeah, that's correct. At the surface, temperatures could reach 4,000. Yeah, it's 4,000. 4,000 Celsius, Benecke estimates, with water existing in a supercritical state, where the distinction between a liquid and gas becomes blurred. It is almost like a thick, hot fluid. Yeah, is it fluid? Hot fluid. Fluid, he said. Both teams detected carbon disfeed. What is this word?
Disulfide.
Disulfide, which is linked to biological processes on Earth, but which can also be produced by other sources. However, there was no sign of another biosignature molecule. And yeah, I forgot how to pronounce this word. Molecule. Dimethyl sulfide. DMS. I can't see this word because it is link. Yeah. We can't tie carbon disulfide. Again, this word. Let's see how to pronounce it.
Disulfide.
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 Disulfide. Disulfide. Disulfide. Disulfide to biological activity, said Madhusudahan. In a hydrogen-rich atmosphere, it is relatively easy to make it, but if we are able to measure the unique molecule, yeah, it came here, so I can't. I think this is Juzayat, but I can't pronounce it.
Molecule.
It's promising that we should be able to measure habitable planets in the future. We need to be extremely careful about how we communicate findings on this kind of object, he added. It is easy for the public to jump on to the idea that we are finding life already. Dr. Joe Bastow, an astronomer at the Open University who was not involved in the latest work, said spectra of these small planets with JWST really exciting because these are brand new environments for which we have no solar system equivalent. Bastow added that further observations to pin down the abundance of water vapor in the atmosphere would help clarify the likelihood of an ocean. It's really fascinating and really nice that two teams have looked at the same data set. I think a data set. Let's see.
Data set
up with the same chemical makeup, she added. Yeah, let's close this one and get